Okay, thank you all for being patient. Let's go ahead and get started. Again, thank you guys for joining us for our webinar on improving tool room and productivity with an integrating tooling solution. Just a little bit on Swoosh. We've been a leading provider and partner of Siemens PLM for over 11 years. Our team is dedicated to providing you the best software solutions, technical support, and process-based training to help you design and manufacture better. Our commitment to changing the way designers and manufacturers learn and leverage PLM tools has been a major focus for us and will continue to be our goal moving forward. Today presenting is Eric Kocher. He has 15 years of consulting, sales, and sales management experience covering a wide array of industries and organizations. He is a certified Siemens PLM sales professional with a passion for identifying potential process issues with providing solutions for better productivity and seamless integration. In today's webinar, Eric will cover the challenges faced by tool design and manufacturing industry and how PLM solutions address these challenges through advanced automation, process simulation, and integrated technology to advance the process, reduce waste and costs, and improve your quality. I'm going to go ahead and switch this over to Eric and let him take it away.
All right, great. Thanks, Elise. Appreciate that. And just to make you guys aware, if you have any questions, we'll take questions there at the end as we go through this. So just to kind of hit this again, we're going to start off with some different trends here in the industry, go through kind of what our solution looks like to address a lot of these trends and challenges, and then again, questions from anybody that's there that has questions regarding what we've gone over. So the last few decades has brought a sea change to the mold tool and die industry, with the introduction of multitask machine tools to increase productivity and reduce turnaround times is one of the most dominant trends in the industry, but it has added more complexity to the process. So with more competition, producing high quality tools at a low cost, price, and time have become the critical success factor in the tooling industry. So this has led to questions such as, how can I deliver high quality molds to my customers faster than my competition? And how can I help my customers design products right the first time? These have become quite common in this industry. Ultimately, the tooling industry is striving to pull together the multiple pieces of the tooling design process, integrate, and manage it within their product development processes. So one of the obstacles that tooling companies face is poor communication with the OEM, who are looking for more involvement and collaboration earlier in the design process. So in order to counter this, early supplier involvement, or ESI, is becoming quite common in tooling companies. And this is the process that brings you and your supplier together earlier in the product development process with the shared goal of getting your products to market as quickly as possible with the highest quality at the lowest cost. Now, you're probably familiar with this diagram. Essentially, the first step in the process is for the mold manufacturers to receive data, commonly referred to as a database, from their customer. So this database can include STEP or IGES files. Sometimes the data arrives in a native CAD format, must be translated. Once that's obtained, it's then analyzed for data quality, moldability, and part properties. What we do is then check and make sure that if there's any repairs that need to be made, checking for correct draft angles, looking at volume, surface area, wall thickness, and things like that. This ultimately affects the potential cost and quality of the resulting mold part. So when those issues are identified, they're corrected, and then if that database is altered in any way, it's important to go back and review the design changes with the customer. After the customer signed off on the design and any preliminary tool designs, the mold manufacturer begins the detailed design of the tool. Now, one of the important takeaways from this diagram is there's some different areas there where bottlenecks can start to occur. When the files come in a different format, if there's a lot of changes that need to be made, the constant loop back with the initial customer in order to review those changes and ultimately come upon an agreed upon time frame. So given the new landscape, just about every surviving mold and die shop knew that they needed to make changes. The best in class, those that are really achieving the best quality and efficiency out there, have moved to increase this design efficiency. So as a result, they've reduced their job turnaround times, and they've adopted strategies to offer value-added services. This way, they don't have to compete necessarily on price alone. Now, what this has done is this has created big gaps, big performance gaps in the industry. Those that have adapted and embraced a lot of these trends, they quote accurately and on time 96% or better, while those who haven't adapted or haven't embraced these trends only deliver accurate quotes 43% of the time. They also deliver tooling on time with higher quality on a 99% or better average compared to 53% with the other companies that haven't. So how is it that they've achieved these type of numbers? Adopting the right technology along with a combination of people and process is the key. So these businesses use integrated CAD, CAM, CAE software along with design automation in order to eliminate manual and mundane tasks so that they can respond faster. They use simulation and design for manufacturability to optimize the manufacturability of that part and tooling. And they've implemented a PDM or PLM system to manage tool designs and find the right data quickly. All of this to address the previous chart and make sure that a lot of those bottlenecks that exist are eliminated or at least smoothed out so that you can get the designs, get to the manufacturing and go from art to part a lot quicker. Some of the companies that have been successful with this, I'll just run through a couple of quick case studies here. Shridevi Tool Engineers, they provide molds to white goods and consumer product manufacturers, including Honda, Yamaha, Ford, Fiat, and a couple of others. They decided to bring the design work in-house. They implemented NX because of its advanced functionality for mold design and user friendliness. They've seen immense benefits so far. Mold designs completed in half the time, development cost savings of more than 40%, and productivity gains of more than 50%. We also have Minco Tool and Mold. They're a major plastic injection mold manufacturer in the US with 50 years of experience. In order to capture a niche in the market for manufacturing complex shaped parts, they use NX Mold Design and NX CAM. The model-driven process, which we'll talk about later, in NX, powered by the master model, ensures easy and accurate design changes from product to NC programming. And this integrated solution is key to their success. So they can achieve high quality manufacturing by maintaining accuracy in product design, tool design, and CAM programming. And then finally, we have Miraplex Molds. It's a manufacturer of molds with 25 years of experience, and they chose NX because of the integrated CAD and CAM solutions. With NX, mold design and toolpath creation takes place concurrently. While the tool designer is finishing the mold, the CNC programmer can start the programming work in NX CAM. This is possible in spite of the fact that many design changes are still coming in from the customer because of how easily the NX geometry can be changed. This efficient manufacturing process has reduced the overall mold development cycle by 35%, and the high speed and precise tool paths can be updated 50% faster after those design changes have been implemented. So how did they get here? We often hear that there are discrepancies or big gaps between product design and what happens on the shop floor and what is really defined within the system. Another common issue is information silos and problems such as manufacturing not involved in design discussions early enough. The process starts with input from part design data, usually a 3D CAD model, using some sort of CAD software. This data is used as input for the manufacturing engineering. At this stage, this is the machining and inspection methods for the part are defined using CAM, CAM, or other related software. And eventually this data is used in production. Bridging the gaps in the process is the key challenge for manufacturers. I mean, it would be a big benefit if companies could bring all engineering and manufacturing information into one place so everyone can have a clear understanding about how the process is expected to perform and how it's actually performing. The effectiveness of this sequence can significantly impact the value you realize from your manufacturing equipment. So to start off, we're going to look at product engineering and some of those challenges that have been identified by the early supplier involvement. Typically, mold designers are usually creating mold geometry from an existing part geometry. This part geometry can come from many sources, including customers and suppliers, and often it's not in the same data format the mold designer is using. So this causes translation issues that make the designs take longer and increase the chance for errors. Another challenge is turnaround time. Turnaround time is a key competitive advantage for mold designers. Having to recreate geometry from scratch increases that turnaround time, which leads to higher costs and unhappy customers. And then finally, fast turnaround doesn't mean much if the design isn't right. So being able to make sure that it's right quickly not only increases quality, it also increases confidence in those designs. So what is the solution to this? Well, with the industry's broadest suite of integrated and proven software for manufacturing, Siemens provides you with a unique and powerful advantage. NX is the leader in not just reading data from multiple CAD sources, but being able to work with and modify it. Tools such as synchronous technology give NX unmatched ability to work with multi-CAD data. Automation and reuse are the keys to fast turnaround. With the NX reuse library, this enables you to take, as the user, to take advantage of existing proven designs. And the NX Mold Wizard automates the mold design process by making it easier to follow with a step-by-step approach. And then finally, early validation is another strength of NX. With applications such as DFM Pro and Easy Fill Analysis, these are among the tools that NX Mold Designer can use to verify their designs and make sure the job is done right the first time. So taking a look, we'll take a little bit closer look at the multi-CAD and how this helps you work with CAD files. So there's two key areas that we focus on when it comes to use and modifying CAD data within NX, and that's multiple formats and synchronous technology. NX has the ability to read and modify data from multiple CAD systems. This is just a short list here on the screen that show the different file formats that we work with. This includes mainstream CAD systems as well as neutral formats like IGES-STEP or JT files. Basically, if you have CAD data, you will be able to read it within NX. Now, with synchronous technology, this data can be modified as needed, eliminating slow, error-prone translation, offering fast, intuitive design creation, and easy modification without having to know how that design was originally created. Now, when it comes to automated design tools in the process, NX Mold Wizard embeds tooling expertise into NX. This enables you to create molds based on the product model with fully associativity between the two. So using mold base and standard part catalogs, along with integrated reuse library, you can easily take advantage of existing proven designs. Generating those fully detailed drawings for production is highly repetitive and also time consuming. With the NX Mold Wizard, this automates that process, producing drawings for inspection, shop floor assembly, NC, and other uses. And it can all be done with just a click of the mouse. Finally, Mold Wizard applies a process wizard technology. Essentially, this automates the tools and the abilities within NX to design the molds, to design those molds. Providing a structured workflow based on best practices, automation of mold-specific design tasks, and those libraries of mold components. This provides you a step-by-step process that promotes the most efficient workflow while integrating complex elements of design technology into those sequences. Several of the capabilities, just to list a couple of them, are advanced parting tools driven by the power of NX, manufacturability checking for molded parts, automatic core and cavity inserts, or model swap for automatic updates to compare new versions. So validation is the third part of this. Getting the job done right the first time depends on early validation of your designs. So we have various tools within NX for ensuring mold and part quality, including the ability to analyze draft, shrinkage, parting lines, cooling, and many others. In addition, DFM Pro, which is also integrated into NX, doesn't just check to see if a part is manufacturable, it suggests corrective actions if it's not. And then there's also mold flow simulation, and this is integrated into NX well. It allows you to check for mold flow issues before any expensive parts have been made. Poor molded part design can negatively impact the quality. You'll see a short video there on the side that shows NX taking you through the validation process. And what this does is this identifies and eliminates many of the issues highlighted on this slide: shrinkage, moldability, warping, sinking, wall thickness analysis. And it suggests how to eliminate those issues if it needs to be healed or repaired because of the data. Also, the quality of the tool can be validated. You see another short video there on the side that shows a simulation of the tool. For example, avoid blowouts by using NX Strength Wizard, or increase the life of the mold by detecting and removing sharp corners in the part. In some cases, NX CAE can be used for performing advanced cooling analysis and motion simulation. So really, you can check and make sure that you can check for interference or collision-related issues during this simulation piece. So the mold design data from product engineering is then used as input for the manufacturing engineering in the tool room. Here the machining process and inspection methods to manufacture the mold are defined using CAM, CMM, and other related software. The output is in the form of G-code, inspection programming, tooling data, and work instructions. It's all generated and sent to the shop floor. Then once on the production shop floor, this data is used to set up and drive the manufacturing equipment to machine the mold components. So what are some of the typical challenges that you run into in the tooling? Inefficient processes can really affect production in many ways. For example, when manufacturing companies try to fit separate software applications together, it often results in a process that requires multiple data conversion. This is very similar to kind of what we talked about at the beginning when it comes to product engineering. You know, when things are coming in different versions and different formats, it can really slow down your manufacturing time. To be competitive in today's environment, manufacturers need to increase their throughput. So, for example, when the CAM software doesn't provide a complete set of CNC programming capabilities, or when it lacks application-specific functionality, it can reduce your efficiency, you know, having to hand program your machines. And finally, achieving reliability in the manufacturing process ensures consistent production quality. So how do we solve this? In order to be competitive, mold manufacturers need to synchronize the entire manufacturing process, maximize the machining efficiency, and ultimately hit the production targets. So let's look at how we can help address these challenges. When it comes to running a more efficient and nimble business, all the manufacturing activities need to be synchronized. Siemens PLM provides an integrated software solution to support the entire manufacturing process, from CAD/CAM all the way to the CNC controller on the shop floor. Our model-driven process lets you collaborate and work concurrently. This all starts with the part model that needs to be manufactured. You saw the advanced tools that let you create a mold assembly for the part model. Well, let's see how this part model drives the entire manufacturing process to machine the mold assembly. So the mold design is input into the manufacturing process, and then ultimately goes through two stages. The top half of the diagram describes the process to define the process to which you machine the mold. Using CAD design tools, you can quickly prepare the mold for machining and also design the fixtures. The next step is to define the machining for the mold by using the CNC programming capabilities in NX CAM. This lets you achieve high-speed machining and high-quality machined surfaces. To ensure first-time machining, the CNC program can be verified in NX by using the G-code-driven simulation. And then finally, a complete set of shop documentation can be easily generated. You can transfer CNC programs, tool lists, setup sheets, and drawings directly to the machine tools on the shop floor. Now, while all of this is happening on the top half of the diagram, at the same time, you'll now see on the bottom half of this diagram, defining the manufacturing process for the mold. Your team can work on the electrode machining using the same unified NX system and working on the same data. They can design, prepare, program electrodes that are part of the mold assembly. And besides CNC programs, NX lets you create inspection paths to drive CMM machines. The output of the electrode programming step, including CNC and inspection programs, is transferred to the production to drive the manufacturing equipment. This model-driven process ensures three things: associativity to the supply design data, concurrent workflow, and accuracy and reliability. Many mold manufacturers around the world leverage the NX integrated platform to maximize their overall productivity. So NX CAM also delivers real differences through key capabilities such as its advanced programming, integrated post-processing, and simulation functionality. The optimized CNC programs and the complete shop documentation generated by NX CAM can maximize the productivity of your machine tools. So looking at these independently, the intelligent tool paths ensure efficient machining and increased productivity. For example, you can quickly remove material on your molds with high-speed machining capabilities, or NX CAM lets you automatically tilt the tool so that you can use the right tool to improve the surface finish. Next, with advanced feature-based machining, This provides extra value in programming automation. Essentially, the system automatically identifies machining features and then it applies machining operations. This capability is particularly useful for programming mold plates that can have many features such as products, slots, and complex holes. With this feature, with featured-based machining, you can reduce your programming time as much as 90%. And then finally, the machining data library and process templates enable you to apply proven data and processes. This knowledge-driven programming can improve your productivity and ensure repeatability in the manufacturing process. When it comes to advanced capabilities, NX-CAM is optimized for mold and die manufacturing. High-speed manufacturing for hard materials can significantly reduce machining cycles. For example, the high-speed roughing in NX maintains high metal removal rates while managing tool loads. You also have superior surface finishes that can be achieved by using the available smooth-flowing cutting strategies that can flow critical contours of a part, resulting in fine finishes at high feed rates. And then having full control of the machine enables manufacturers to reduce risk and improve quality. You can preview, change, and reorder the regions and the associated operations before generating tool paths. The close connections between engineering and planning enables the manufacturing team to achieve the right control of the manufacturing process. And Siemens offers advanced technology that can connect your engineering and shop floor teams. So a lot of this is a mundane and repeatable tasks. So completing shop documentation, including programs for your specific equipment, tool list, setup sheet, and drawings. These are all essential for machining right the first time. With NX, you not only generate the complete work package, but you can also validate CNC and inspection programs. So that way you can minimize testing on the shop floor and you can speed up ramp up time. You can also deliver manufacturing the planning data directly to the machine tools. Extending PLM to the shop floor opens up new possibilities. For example, elimination of duplicate data and better workflow management from design through to manufacturing. And then as the shop floor team uses the data provided by engineering to run the production equipment, it's critical that the latest production data is sent back to engineering. For example, quality inspection results from the CMM machine, those can be collected and sent from production back to engineering for analysis in NX. This closed loop solution ensures that the entire manufacturing team uses consistent and up-to-date information that enables a more efficient manufacturing process. One of the key advantages of having an integrated solution is that it enables efficient design change management. When a new revision of the product model is introduced, the design changes easily propagate throughout the process. So in summary, and to conclude, the chart there on the screen summarizes the breadth of our solution for design and the manufacturing process. As we saw in this presentation, the path from initial CAD model to the production phase is tightly integrated in NX, leading to significant productivity gains across the entire tool development and manufacturing process. So that leads us to, I think we're running up on the close to the end of time. We want to be respectful of that. But Elise, were there any questions that have come through?
Yeah, we do have a couple questions, but I mean, we might have time for a couple. Let's see. The first one we got was, is this something that we can roll out in stages, or do we have to rework the entire process?
So great question. We can work with you to see where you are in this process, and whatever stage you're in, we can help develop a strategy that makes sense for your organization. So maybe you need to isolate your design phase and improve efficiency there first, and then build to other areas. What we can do is help you evaluate where your current process is, where some of those bottlenecks and areas for improvement are, and how we can help you put you on a path to improve those areas in a staged or phased in process. Also, if you have those tools already in place and want to expand your knowledge, we can help with the training on that as well, to make sure that you're getting the full value of the process that you have in place.
Wonderful. Thank you so much, Eric. I think we probably are out of time now. But in case your question was not answered, please let you know that Eric will reach out to you via email to make sure you do have an answer to your question. Also, make sure that you look out for the replay video, which will be hitting your inbox in the next couple days. And we, of course, post all our videos on our YouTube channel, so you can always reference it there. So thank you again for joining us today. Thank you, Eric, for the presentation, and I hope you all have the rest good rest of your day.